Welcome to the 74th Annual Cold Spring Harbor Symposium. This year the theme is evolution, and we have a very broad range of topics under consideration here. My guests today are two people who do not have laboratories in evolutionary biology, but whose opinions and whose influence on the field are both significant. On my left, we have Genie Scott, who is the director of the National Center for Science Education in Oakland, and next to her, Daniel Dennett, the professor of philosophy at Tufts University. Both of them are here because, in my view, they are crusaders for Darwinism, but they go about that good work in very different ways. Both are occupied in different ways with the idea of design, and I hope that in this conversation we will get into that. So welcome back to Cold Spring Harbor to both of you. Genie, I'd like you to tell us first of all what the Center for Science Education does. I know it's known to many people in the scientific community, but I think it would be good to hear it from your own lips.
Well, the National Center for Science Education is a nonprofit organization. We support ourselves by memberships, contributions, and occasional private foundation grants. We're not affiliated with any university or anybody else. And our members tend to be scientists, teachers, civil libertarians, interested parents. And our concentration is the education in the nature of science and evolution education. And somebody always asks me, well, why do you call yourself the National Center for Science Education? It sounds so broad. Yep. And I'm not to blame. This was something that the original Board of Education back in the early 80s decided was a good name for this organization that actually was assembled originally to try to keep legislation that was rampant in the late 70s and early 80s, legislation that would require teaching creation science whenever evolution was taught, keeping this legislation from being passed at state legislatures around the country. Yeah. So these poor souls thought that once the evolution issue is taken care of, then we can move on. So science, yeah, right, exactly. Scientists and teachers working together is a really powerful combination. We could do lots of good things, and of course we're still up to our nostrils in creationism 20 plus years later. So there you have it.
Yeah. And, I mean, we'll get into later perhaps why we are still there.
Actually, I didn't answer your question. What do we do?
What do you do? Exactly, yes. I mean, I know.
That's the structure of it.
Yeah.
We actually are unusual for a science-oriented organization because we work at the grassroots. You know, we're this very odd hybrid of an activist organization and a scholarly organization. I mean, I do consider that we're really studying this, and you know, we're all a bunch of ex-academics anyway. But really, our bread and butter activity is that we are out there providing teachers and school boards and parents and scientists with the information they need to know if they're going to cope with this problem in the schools, in the state legislatures, in the state boards of education. So we're really much too small to go and solve all the problems in the 15,000 school districts in this country.
Yes.
But we do provide the information so that local people can do the work. And we work closely with state organizations around the country.
So the more scientists you have with you in this coalition...
Scientists are the backbone of our organization. Yeah. Always have been.
And so anybody who wants to join the good fight should...
They would be welcome.
Yes, should be contacting you. Yes. Is it fair to say then that you are providing resources for those who are already convinced rather than resources for those who want to be convinced or are confused?
Well, we're actually not trying to convince anybody. I mean, we're trying to get people to understand the science. I mean, my feeling is that if people really understand the huge amount of data and theory that support living things descended with modification from common ancestors, the rest falls into place.
Yes.
There are, in the United States especially, but really it's a North American problem and creeping more and more in parts of Europe, there are religious traditions that reject common ancestry, that reject evolution. some of them never will accept it. But part of the problem is that there are mainstream Christians in the United States whose theology doesn't require them to reject evolution, but they do because they don't know their own theology.
Yeah.
And so we have a variety of sorts of information on our website, mostly scientific, a fair amount of pedagogical information. How do you teach evolution better? And we also have a section of our website that provides information on the range of Christian views toward evolution.
Right.
And, people can find that a useful thing.
So I have to ask, is it working? Given that we know the struggle continues.
Sometimes it's the Red Queen. I mean, sometimes I feel like we're running as fast as we can to stay in the same place.
But it's working. It's working. Believe
think
me,
so.
it's working. Yes, yes. It's a tough battle, but you're winning the battles that you're fighting. And
thank you. I appreciate you understand. Yes,
and
that's
I
true.
I think that's important.
Yeah.
As a longtime member of the NSC. And CSE, I applaud their work. I think it's very important that there be such a group, and more power to them.
I think it's really true that if we hadn't been here for the last 20 years, things would be a lot
Things
worse.
would be worse.
Things aren't
Yes.
perfect.
Yeah.
I mean, we
So
20 years we haven't solved the problem. I don't think we're going to go
Yeah.
home in despair. That's,
And I mean, the Dover verdict was one of the high
that was
spots
a
of
real-
the,
yeah.
It was a very-
the centers.
And
That was
the
really
center
important.
played a good role in that.
Oh, yeah.
A very big
we
role,
we
yes.
were the advisors to
Yeah.
the plaintiff's legal team.
Yes.
Yeah.
And I personally was behind the scenes. Actually, people always ask me, well, weren't you a witness in Dover? No, because if I were a witness, I would be restricted in my ability to work with the lawyers. And
Yeah.
so I was actually more valuable,
Yeah.
so to speak, being on the inside.
Yes.
But we helped to pick the expert witnesses, and we helped to give them the information that they needed we helped the lawyers with the questions that they needed to depose the other side's expert witnesses. So we were involved from day one, literally.
Right.
It was, and if we had lost, it would have been a bad thing.
A very bad thing, yes.
What do you see as the beneficial consequences of winning?
One very important consequence is that we were hearing about lots of school districts that were just sort of poised to introduce Dover-like policies. Well, as soon as we find out, we're going to introduce intelligent design into our school district.
And poor Dover, they've got such a problem now. I mean, with the legal bills and all that, and I
Yeah.
think that in itself will throw buckets of cold water on some.
That's
on
discouraging.
some-
Yeah.
Yeah.
But a lot of them just pull back when
Yeah,
they.
yeah.
But if nothing else evolves, creationism does, right?
Yeah, yeah,
because
yeah.
the next thing that happened is that intelligent design just sort of reorganized
Yes,
itself and
yes.
leaped forth in a new venue.
So let's bring up the question of design. Dan, your book, your 1995 book, Darwin's Dangerous Idea, was in many ways preoccupied with the idea of design.
Yes.
And you even gave it a capital D in your manifestation of it.
Yeah,
But there was a complex book full of ideas. Could you encapsulate your idea of design and natural selection's
Yes.
work upon it?
I think that there's controversy about this. Some people say that they want to say that what evolution by natural selection explains is apparent design, not real design.
Yes.
And whereas I don't take that line at all. I say, no, there's real design. Natural selection explains it. You can have design without an intelligent
without a
designer.
designer.
But it's design. It's just as much design. There's an important sense of design. You want to acknowledge that it's design. And I think it's actually very important to take that strong line on this because, for instance, we have Archbishop Schönborn saying in the New York Times that anybody can see, people can see by the light of reason that the natural world is full of purpose and design, and so it is.
Yeah, the stuff
And
works.
so it is. And
Full
saying,
of design,
and
anyway,
it's
if
full
not
of
purpose.
But
well,
it's
well,
full
no,
of
there's
it's
plen-
full of
there's plenty
stuff that
purpose.
works.
It's-
Yes.
And that's really what we're.
and full of animals that have purposes, for instance, even when they don't recognize them. And I think what you want to do is acknowledge that and say, isn't it amazing that all of that design, all of that purpose can be accounted for by a process which itself has no purpose and is not a design process. That's Darwin's brilliant idea, and it's a misunderstanding of that. I think you foster misunderstanding if you say, well, what natural selection argues is that there isn't really any design in the world. No, it's breathtaking how much design there is in the world. It's just not so-called intelligent design.
Part of this also is how you define design too.
Yes.
I mean, you know, when I think, and evolutionary biologists tend to use these words very casually, very much like we do on the street, which is not necessarily bad. But you know, we'll talk about the design of a deer's forelimb, right?
In fact, I think this is not just casual. I defend it, and I think because basically, as I argue in the book, what biology is reverse engineering at every level, from the molecular, the talks we heard the first day here about the brilliant engineering of the ribosome, just breathtaking. And engineers, their mouths water when they see this, because they recognize this is what they do too.
But it's not all perfect.
No, but it's not.
Yes.
No, but it's. The thing is that there are rationales for the designs. There are reasons why the parts are the way they are. They're not represented by Mother Nature. They're not represented in the mind of God. They're not represented anywhere until some engineer or biologist is clever enough to figure out what the reasons are. But you go hunting for reasons, you find them. And for me, this is actually the centerpiece of my whole philosophical position, because I had the so-called the physical stance, the design stance, the intentional stance, and the design stance was characterized as something which both biological things and artifacts have in common, is that they are compactly describable from the design stance, and that you can make predictions that are much better than a coin flip using that stance. And that's, I think, a very important point. There's a precise way in which animals and artifacts are amenable to the same theoretical treatment. There are differences.
You have to be careful. It's a useful way of understanding the fact that in biology there's a lot of complicated moving parts that make something work. You know, you elongate the tarsal bones, and that increases the speed of an ungulate. I mean, there's a lot of stuff that has a function. I mean, a lot of times when we talk about design, we're really talking about pieces of material that get something done. That's very different from an artifact when you conceive, which I think most people conceive of an artifact as, using Michael Behe's terms, a purposeful arrangement of parts. If you think of, a purposeful arrangement of parts is like you've got all your carburetor pieces on the garage floor and you put it all together at once and it works. And that's the way they're looking at the bacteria flagellum. That it was something all put together at once.
Well, I think that Michael Behe's use of the word purposeful there is, as it were, artfully ambiguous. I think that the arrangement of parts that you find in biology is purposeful.
In the sense that it gets something done.
Well,
you know.
Not just that it gets something done, but that typically it gets something done in about the most efficient way anybody can imagine. That evolution optimizes again and again. That for instance, the efficiency of enzymes goes up by orders of magnitude under evolution. That's purposeful arrangement of parts.
Yeah, but look at something like the blood clotting cascade. If you were going to start from scratch and make something to make your blood clot, you wouldn't make that way. But if you look at the blood clotting cascade as something that's had a history, it makes sense.
Oh, sure. But actually the same thing is true of human engineering very often, too. There are lots of vestigial traces that are no longer playing design roles in human artifacts, too.
The Microsoft Windows operating system, for example.
Oh, yeah.
Well,
unclean.
Do
you remember the Harvard Lampoon?
Sure.
Years ago.
Yeah.
They had an issue. Harvard Lampoon, it's a college humor. And they had an issue called Popular Revolution, which was just a stitch. I think probably someplace in my files I still have it.
No.
But it was a takeoff on popular mechanics, except it was all this wonderful Lamarckian evolution stuff. And one of the things that I remember from one of the little articles there was how you could take a toilet seat and make a violin out of it.
Mm-hmm.
Now, that's what evolution does, okay? If you're going to make a violin, you don't really start with the toilet seat. But if all you have is the toilet seat, you sort of elongate this part and you put the strings across here and you make a little basin, and you can get a violin from a toilet seat. But you wouldn't do it like an engineer would do it.
Well,
I mean, or I should say, evolution doesn't do it like an engineer would do it.
well, yes and no. And I talk about this at some length in the book. There are some important differences between the way evolution designs things and the way human engineers design things. For one thing, engineers, when they design things, they very often do divide and conquer because they're worried about unforeseen side effects. So they try to isolate subsystems from each other so you don't get what in software is called clobbering, where one thing undoes the work of another thing. And so human engineers have learned to isolate and insulate components. Evolution, having no foresight at all, doesn't bother doing that. And the result is that very often you get these elegant serendipities, these coming together where something can serve multiple functions, something that you rarely get in human engineering. You do get it, but it's quite remarkable, it's quite rare. There's usually unifunctionality in human design and multifunctionality in evolved design, but we can compare them, we can analyze them in that regard, and again, biologists looking and scratching their head about why the parts are arranged the way they are, turn out, when they figure it out, to have underestimated the elegance of the engineering in the biological case.
But also contingency, remember. I mean, that's another difference. Now, it's true that engineers are affected by contingency.
Sure.
There are qualities of the metal or whatever material it is. But evolution is contingency cubed. I mean, evolution is really stuck with that toilet seat out of which we're trying to make a violin. I mean, evolution has a tougher time of it in one sense, but actually it's better at it, and that's the wonderful thing, as we've seen with the genetic algorithms and the drug design, where they've just sort of let the chemicals
again the evolutionary process comes up with a more efficient and potent solution to these problems than human engineers trying to solve the same
like
problems.
Rick Lenski's Avita program. They have. Are you familiar with this? This is a computer program where they have created, as it were, digital organisms, which are rewarded by acquiring energy so that they can reproduce, basically. But then, basically you establish the environment. Here's the world you're living in. Here are the rules of the world. Now let's sit back and watch it. And they will come up with all sorts of interesting evolutionary developments, like being able to do small logical operations, if that's being selected for. But they do it in ways that an engineer wouldn't do it. They do it out of this random variation and selection algorithm that we associate with Darwin, and do it in ways that are not necessarily mainstream, not necessarily drilling right down to it, but often coming up with ultimately a more elegant solution by this kind of, and that's the thing that people don't understand.
Well, I think that's true, but at the same time, for many years, even before Darwin's dangerous idea, I was writing about this, and I suggested that if we look at organisms that have been artificially selected, for instance, if we took a greyhound and a cheetah and sent them off to a Martian biologist and said, one of these is a product of foresightful, purposeful selection, one of them isn't, can you tell which? The answer is no, you can't tell. You can't tell. That there are no reliable marks of either natural selection or human engineering, except that very often you get botched human engineering. But
you stacked the deck on that one because cheetahs went through a bottleneck. If I was a Martian biologist and I was looking at greyhounds and I'm trying to think of some other combination.
Ferrets and dachshunds.
Okay, good. There would be a whole lot more genetic variation in the population of ferrets than there would be in the dachshund. That would be one clue. But if you only had a dachshund and a ferret, I concede.
Yeah. The point.
The thing, evolution leaves tracks. I mean, history leaves tracks in the genome.
Yeah.
And
That's true.
that's the kind of contingency that I was talking about.
But
I don't disagree with that at all. But I just think
we're actually agreeing all the
yes,
time.
no,
We're just having fun.
I take your point, but if you talk to the people who have no scientific background, and inevitably evolution comes up, and the figures, as you know, the figures of in the American population who are willing to declare a belief in what continues to be called the theory of evolution. I think it's about 39% or something.
It's close to half.
Yeah,
but it should be more.
The public is uncomfortable with the idea that complexity of things that they understand enough of the complexity, say, of the eye. They have no grasp of the mechanisms by which that level of complexity can be achieved.
That's why Paley was so popular.
Yeah.
Paley had a very nice explanation for that.
I think the explanation, the key to the explanation of why so many people don't believe in evolution is very simple, and in its own way, it's fairly benign. We all take a great deal of what we think we know from people that we treat as our experts, our authorities. I can't prove for myself most of the physics that I take, that I know, because I listen to physicists and biologists and historians and so forth. We all have our experts. And for many people in the United States, their pastor is their expert. And I don't blame them for thinking, well, look, the pastor said it. It's got to be right. I say that, my doctor says it. I think it's probably right. My physicist says it. I think it's probably right.
Reliance upon authority.
We all rely on authority, and I don't think that it is foolish or stupid or anything like that for people to rely on authority. I blame the pastors, because I think that they abuse their authority when they, not knowing
stray
much
into
of
realms
anything,
they don't understand.
they say from their pulpit that these things are factual and these things can't be right, and they jolly well don't know. Now, I think part of our job, I think part of Genie's job as well, is to draw attention to those pastors who are responsible and who say, look, our church has made its peace with evolution, and evolution is a fact.
Yes.
And this does mean some serious adjustment in many churches. Not in all. I mean, it means serious adjustment in all churches. Some churches have simply done it already.
Yeah. Yes.
So for them,
there are consequences.
For those advanced, in one sense of the word at least, churches, there's no longer a conflict. There certainly was a conflict, and for many churches in America, for many religious sects in America, there still is a conflict. I think we should acknowledge that conflict still exists, and I think we have to be firm and say, and these groups are going to have to
step up.
They're going to have to step up to the plate and learn that they can, that they're wrong.
Well, they are certainly wrong when they make pronouncements about science, and that's what we're concerned about. Yeah. But I don't really think that most people reject evolution because of how the Grand Canyon was cut.
Yeah.
Okay. I mean, I would take it back one more step. I agree with you all about the authority across the board, and especially the authority of the pastor. But you don't go to your pastor if your plumbing doesn't work. You go to your pastor for guidance and religious guidance, and that's the bottom line.
Well, but so why do they go to the pastor when they ask about evolution?
And is science to blame?
It's because evolution has consequences for feelings of purpose, for the human exceptionalism that is still part of a lot of Christian denominations. And the pastors are responding to that and really just pulling the Grand Canyon and pulling the science in as a way of buffering that position. So, fundamentally, we need to get them talking to other Christians who have made that peace that you were describing, because it's fundamentally a theological issue. I mean, we're not going to solve this problem by piling more science on it. Okay. Trust me on
So,
this
I mean, you were saying, Dan, that the pastors are to blame, basically. But does science have some responsibility here in
Science
not
tells us
giving?
how to understand the natural world.
But how well do scientists communicate an understanding of the kind of complexity that I alluded to? It's hard to do that, and scientists are much more concerned with talking to their peers often than they are with talking to the public.
Well, at least in the United States, most scientists, I actually don't know the proportions of the scientists working in industry, the scientists working on campuses and as teaching at universities. But for those who are teaching, for those who do work at universities, a big chunk of their responsibility, in addition to research, is teaching. And I am constantly haranguing our colleagues at the universities, do a better job teaching evolution. Because those undergraduate students that you are teaching in your intro class and in every other class are going to grow up, some of them are going to grow up to be high school teachers, and if they don't understand evolution well enough to teach it, if they don't understand the nature of science well enough to teach it, buck stops there.
Yeah, I think we have some very serious shortcomings in science education at the pre-college level, and part of it is actually because with science in such demand, teaching science in a high school is not a very lucrative way of using your knowledge of science. So we have to do something about that, but we also have to do something about the fact that in still so many school districts, I think one of the big problems, I wonder if Genie will agree with me on this, I don't have data on this, you probably do, is a sort of prudent self-censorship on the part of biology teachers in high school. They don't want to lose their jobs. They don't want to make a fuss. It's not that they don't believe in evolution. They do. It's not that they don't understand evolution. A lot of them do. It's just that
don't put up with the flags.
They are not.
They're dealing with families.
They're not in a very secure position,
yes.
And so there's a strong temptation to button their lips. And I think, I think we can't ask them to be heroes. And we can't ask them to jeopardize their jobs. So what we have to do is get out there and support them so that they don't feel afraid to say those things. And we have to keep the very aggressive parents off them. We have to show school boards and principals that this is unacceptable behavior. And we have to really make it clear to those school teachers that they can teach evolution calmly, straightforwardly, and not be risking their jobs, and not be risking that somebody's going to try to run them out of town.
Yes.
Yeah, there really is a lot of top-down in school administrations and districts. Most state standards require the teaching of evolution. They vary, but it's in there, okay? And most districts will therefore grab the state standards rather than developing their own, and so most districts will assume require the teaching of evolution. But like you were saying, when the classroom door is shut, who knows what actually takes place? And if the teachers who know that evolution is there in the curriculum, if they know that they are expected to teach it and that they're supported in teaching it, and if citizens, not just scientists, but all citizens, make it clear to the school board, I want a good science curriculum to be taught to my kid, and that includes evolution. Now, you're going to make that happen, won't you? It'll happen.
I think that's a main step that we have to take.
Not that we have to be harassing the teachers. That's not what we're saying either.
No.
I mean, we don't want to be the obnoxious parents. We want to be the supportive parents.
Yeah.
But they have, you know, I do know teachers. I don't have actual hard data because nobody's really done surveys like that. But I certainly have lots and lots of anecdotal information about teachers who have been told by their superintendents or by their principals, just knock off evolution this year. You have little Sally Brown in your class this year, and you know her mother raised that big fuss last year about HIV education or something.
That's
so
another.
you know,
I was going to
cool
say
it,
that's
you know.
another.
Let's
hot
just
button
skip
issue in the
evolution.
same way. Yes.
Yeah, that's it's
And that drives me nuts.
it's that self-censorship that
Yes.
that is the real problem.
Yeah.
Right. Well, that's a clarion call for action, I think, from both of you. So I think we'll wrap it up there. Thank
Good
you very
teaching,
much.
you know, teach evolution better, and let your local school board know that you want good science to be taught.
Yeah.
Right?
Good.
And join NCSC.
Of course. Thank you both very much for sharing your views with us.
Thank you.
Good.